Hello, this is part one of factoring practice problems. So we're just gonna we're literally gonna do some practice problems from all the rules that we have learned from factoring. So let's start with example one. We're gonna do 20 problems, and I'm gonna probably break this into like 2 or 3 sections. Okay, so let's look at the directions. Practice factor completely, do not solve. So we have 2a minus a squared. We have exactly 2 terms. So the first thing I would do is always check if you could take out a GCF. So yes, we can. We can take out 1a, right? Because this term has 1a, this has 2, so the biggest amount of a's you can take out is 1a. Good. And then you need a 2 because you want in order to get the first term 2a, you need a 2a, right? And then you need a minus, and then you need one more a to get the second term a squared. And that's pretty much it. It can't be broken down anymore, so this is your final answer. Okay, so go ahead and pause, and I'm going to move on. Number 2, factor completely, do not solve. So we have 6x squared y squared minus 9x5y. So let's start with the letters. Let's start with the letter y. Well, first off, we have 2 terms, right? So that's good to know. So I always check if we can take out GCFs, and I think we definitely can. Let's start with the y. We have y squared and y1. So the biggest amount of y's you can take out is y, right? And then over here, you have x squared and x5, or 2x's and 5x's. What is the biggest amount of x's you can take out? X squared. And then let's look at the constant. We have a 6, and then we have a 9. So what is the biggest amount of x's you can take out? Or what is the biggest number that they both, the 6 and the 9, can be divided evenly? 3. That's the biggest amount. Okay, so what do you have to multiply 3x squared y to get the first term? 6x squared y squared? Well, you need a 2 because 3 times 2 is 6. Do we need any more x's? No, we're good with the x's. Do we need any more y's? Just one more, right? Okay, now let's look at the second term. What do you have to multiply 3x squared y to get 9x5y? Well, you need a -3 because 3 times -3 is -9. And then we need, how much x's do we need? I think we need 3 more. Because when you multiply, you're adding, so 3 plus 2 is x5, and no more y's. Now, can the inside parentheses be factored anymore? I don't think so. So that is your final answer. Okay, let's move on. Okay, so example 3, we have 2a squared minus 4ab minus ab. So we have exactly 3 terms, this, and this. So let's start with the GCF. Can we take anything out on example 3? I actually thought we could take out a b, but we can't. Because this first term does not have a b. This has a 1b, this has a 1b. So it's because of this 2a squared, it doesn't have a b. We can't take out a b. What about an a? Oh, yes, we can. It looks like they all have, so this term has 2a's. This has 1a, this has 1a, so you can definitely take out 1a. What about constant? So we have a 2, -4, and a -1. So I don't really think we could take out a constant. Okay, so this is going to be 2a minus 2a, right? No, b minus b, because we already have an a, right? Minus 2 minus, no, minus 4a, right? 4b, because we need a negative 4 and we need 1b, and then we need a minus b. Okay, now can this thing here be factored? No, we could have, if this a was a square, we could have tried bottoms up, but it can't be factored, so this is the most factored it can be. Okay. Let's move on. Okay, let's do example 4. We have 4m squared minus 9. So can we take out a GCF? I don't think so. But what's so special about this polynomial? There's exactly 2 terms, right? This is one term, this is the other, and then there's a minus in the middle. So that's a big clue that this is also you're gonna factor using perfect square. So the rule for perfect square is a square minus b square equals a plus b times a minus b, right? So we just got to make it look like you just got to make it look like the it looks like the left, we got to make it look like the right, so we got to figure out our a. So our a is so in our case it's a number and a letter. So what number and what letter when squared gives you 4m squared? So let's start with the number 4. So what number when squared gives you 4? 2. And then m squared is what letter when squared gives you m? M, right? And then your b is, I think it's just a number. So what number when squared gives you 9? 3. Then you just make it look like the right. So it's going to be a plus b, so that's 2m plus 3, parentheses, 2m minus 3, parentheses. Okay, so that is your final answer. Okay, let's move on. Example 5. We have 4y squared plus 20y plus 25. Can we take out a GCF? Yes, we can. We could take out, they're both divisible by 4. No, we can't. Darn it. We can't take out a GCF because 25 divided by 4 it doesn't come out nicely, right? So how are we going to do this? We can't take out a GCF. What's so special about this polynomial? There's exactly 3 terms, right? But what also is so special about this is the a value is greater than 1. So if you recall from our lecture, if there's 3 terms and the power is 2, that's important too. The power is 2, and the a value is greater than 1. There's a good chance you're going to use bottoms up factoring, right? So let's try if it works. So first step with bottoms up factoring is rewrite as if the 4 doesn't exist. So it would be y squared plus 20y. Then what you do is multiply 4 by the last term. That is, so what's 4 times 25? 100. Okay, can this be, now what we can do is try doing simple factoring. Can this be factored simply using simple factoring? So let's see. We need a y and a y here, and then we need to come up with 2 numbers that'll multiply 100, and when added gives you 20. So is that possible? I believe so. It's going to be 10 and 10 because 10 times 10 is 100. And then 10 plus 10 is 20. So it satisfies this and it satisfies that. So you're going to put a plus 10 here and a plus 10 there. Then with bottoms up factoring, you divide these two tens by 4, right? So 10 over 4 can be reduced by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. And then 10 divided by 2 is 5. And then 4 divided by 2. Okay. So you have a fraction that cannot be reduced anymore, right? This 5/2 cannot be reduced. We can't leave it like that. So what you're going to do is, if you have a fraction that can't be reduced, you simply put the number on the bottom, the denominator, in front of the y, and leave the numerator alone. So that would be 2y plus 5. And then do the same thing with this. Put the numerator in front of y, so that's 2y plus 5. So when simplified, notice how this is a repeat. You can leave it like that, or you can say parentheses 2y plus 5 to the square, right? Because they're like a repeat of itself. Okay, so this technique is bottoms up factoring. Okay, I'm going to stop here. I actually don't want to make the videos too long. So yeah, well, there will definitely be a part 2.